In 75 years of average life, we spend more than 38,000 hours, that is nearly 4.4 years, with eating. Obviously, food it is essential to survive and moreover the basis of our daily lives. Due to several main challenges, the way we produce and consume food will be different in the future. The questions are, what are the issues of food production and consumption mankind will face over the next decades? What food production concepts and consumption habits will we have in 2050? And can technology help to solve the major challenges and how? Today, the world population is estimated to be about 7.7 billion. While in 1800 around 1 billion and in 1960 around 3 billion people were living on our planet, the number is expected to grow from today's count up to 10 billion people in 2050. There is a growing concern about whether people will be able to eat and live well in the future because of issues like population growth, accelerated climate change, and increased meat intake, and several more. In the movie Interstellar, humans have to abandon the planet because of the destructive way of producing and consuming food. The filmmakers reviewed several global destruction scenarios with renowned scientists and futurists, and their first pick was food shortages due to the climate change. This is not the first time we had to worry about food shortages. At the end of the 18th century, according to the population theory of Thomas Robert Malthus, the population increased at a geometric progression so as to double every 25 years, while an increase in food production was limited to an arithmetic progression, meaning that the exponential population growth would lead to a shortage of food. Consequently, excess population would stop growing due to shortage of food supply leading to starvation. This is known as the Malthusian trap. Malthus mentioned, "Let the poor die for the others' happiness." However, what Malthus worried about didn't become reality. It took only a few decades to prove Malthus' theory to be wrong. Economists argue that since the emergence of the first industrial revolution, mankind has broken out of the trap. Now, let's find out what kind of challenges regarding food we will face and how to solve them again. The first main challenge we are confronted with is population growth. As mentioned before, world population will reach 10 billion by 2050. If you look at the annual growth rates of the world's different regions, we can see that it is slowing down in the next decades. However, as the population grows, the demand for food also keeps increasing. The second big challenge we face is climate change. It will impact the future conditions of and constraints to agricultural production, thereby affecting food ability and the stability of food supplies. One big problem we experience is that in many areas there is difficult to secure additional cropland. They estimate of about 400 million hectares of highly suitable land available for rain-fed agriculture. Expansion represents 26% of the arable area in use today. More crucially, in regions like North Africa, the Arabic Peninsula, or Scandinavia, there is little to no more room for expansion at all. We can also observe a negative development if we look at a potential additional unprotected and highly suitable areas for rain-fed crop production. Assuming arable land in 2012 as 100 square, arable land will be reduced in most regions by 2050 as shown in the red square. If we now put the main challenges together for the big picture, we have a quite gloomy outlook. Demand rises strongly while supply decreases. The growing population together with the continuation of our current consumption habits will lead to a 14 times higher grain demand by 2050. At the same time, the arable land per capita will see a 20% decrease. The problem is simply spoken, too many people for too little land. However, food production is expected to meet demand in all scenarios derived by the FAO of the UN. The answer? Innovations and advances in technology. They can increase food supplies because there are various ideas and technologies that can enhance food production when facing limited arable land. Yields are determined by the combination of reduction due to climate change and an increase through technological progress. By the change in use of technology, we should be able to offset the negative impact of the climate change. As a result, this leads to an increase in yield. Because of the worry about food shortage, another important discussion is about the possible future food substitutes. The range goes from insects and algae over GMO products to lab-grown meat and 3D printed food. Some of these are already being used or in development. Others still have a long way to go. In the end, what we will have on our plates in 2050 depends mainly on two things: human innovation power and willingness to change food consumption habits for the better of us all. By 2050, most of the world's population will be living in urban areas. Consequently, the imbalance in distance between food producing areas and consuming areas will be intensified. Therefore, we want to introduce two solution approaches based on technology and digital convergence. First, vertical farming is needed to increase the food self-sufficiency of the city and urban areas. Second, in rural areas with comparatively low populations, smart farming is needed to produce food efficiently with less human labor. Vertical farming in urban areas. We need a city that is self-sufficient in the food provision. Vertical farming was conceived by Professor Dixon Despommier of the University of Columbia in 1999. To address food shortages and cropland shortages, he attracted attention by presenting a vertical farm model that could supply 50,000 people through 50-story vertical farms. The biggest advantage is that it can maximize crop yield to area while reducing the risk of crop failure due to unexpected environmental factors. Of course, there are also still many concerns. To operate automation-oriented vertical farms, installation and operation costs are not cheap. So it is necessary to consider whether it is economically reasonable enough to replace traditional farming. Regarding the major opportunities of vertical farming, several advantages can be mentioned. It offers a plan to handle future food demands. It allows crops to grow year-round. It uses significantly less water. Weather doesn't affect the crops. More organic crops can be grown. There is less exposure to chemicals and disease. On the other hand, vertical farming also evokes some grand challenges. It could be very costly to build, and economic feasibility studies haven't been completed yet. Pollination is very difficult and costly. It involves higher labor costs. It relies nearly solely on technology, and one day of power loss would be devastating. To successfully realize vertical farming in urban areas worldwide, innovation will be key. The following aspects need to be given regard to when it comes to innovation in vertical farming. Large-scale plantation will be especially suitable for Middle East countries and countries with 4 seasons. Each public building, apartment building, or household can have its own gardening facility, and an internet platform can be used to connect each facility, which can make an ecosystem for variety. Backup power with sustainable energy sources. Beekeeping in the farm can be a solution for pollination problem as well as for extra profit. Fishy farms, aquaculture can be added to the farm for a more efficient system than hydroponics. Smart farming in rural areas. While vertical farming is a good solution for urban areas, the concept of smart farming could pose a solution for rural areas. In order to improve productivity, farms are using technologies and digital applications like IoT, big data, and automation technologies. Production could be improved dramatically through collaboration and interconnectivity of various stakeholders. As we've seen in the concept of vertical farming, smart farming also offers many great opportunities. Yet, there are also a few concerns regarding the feasibility of concept of smart farming. To make smart farming reality, the key will be collaborative intelligence, using emerging Internet of Things technology, connected to cloud intelligence, community-based sharing economy. One promising approach that has been introduced and used for implementation of smart farming is precision farming technology. Precision farming will use data derived from images in sensors to track crops, soil, and the air in real time so farmers can observe and respond to changes at specific locations also in real time. Variable rate input technologies will add accuracy to planting and fertilizer and pesticide use so that farmers only use what's needed where it's needed, saving chemical costs and labor. Soil monitoring systems will track the overall quality and chemical compositions of the land so farmers can improve fertility for specific crops and deal with local issues like toxicity. Yield monitoring will provide real-time georeference data about crops as they are harvested, including quantity, quality, and moisture content. Drones will monitor farms from the air with data from cameras and sensors feeding into other farming systems. Farm management systems will combine all this field data with insights from wider sources like farm machinery telematics, weather observatories, and global trading markets. In Korea, the government-led smart farming policy has actually increased productivity in the last 10 years. Productivity per person has risen significantly while employment, labor costs, and spread of disease have been reduced. ICT has enabled collaborations between heterogeneous players. There is cooperation among heterogeneous operators that were not expected to cooperate with each other. This collaborations creates a singularity of productivity. To conclude, there have always been times of challenges and revolutions humanity had to face, as we are also seeing right now. ICT technology has been revolutionizing the non-ICT industry, such as agriculture industry. The challenge of future food production and consumption is a major one, but we will be able to solve this one again with the help of collaboration, innovation, and technology. So, what will you eat in 2050?